a little bit better. Now, what we are supposed to do is to get the layer with different sizes, with different thickness or thinness, and we are supposed to get these layers with many different metals. Yeah, it's pretty easy to do that with zinc in case of taking molten zinc, like the example I've given you over here, but it's difficult once we get to the metals that are hard to melt. Zinc can be melted at less than 1,000 degrees centigrade. However, you're supposed to require 1600 to 1800 degrees centigrade when we talk about iron, and even more than 2000 to 2500 degrees centigrade when we talk about manganese or titanium or other strong transition elements, which does not leave us with this choice. We can't apply this anymore. We are unable to apply this anymore because this is not desired. Hence the electroplating. Electroplating is actually used to coat one thick or thin layer of the desired thickness or thinness on one metal on the other. Now, that's what we do with electroplating. And electroplating is very easy. Instead of going with this paragraph given over here, I'm going to go on the next page, page 112, and we are going to take the orange portion first, understand it. We're going to get back to this page and then correlate it with the diagram given below. All right, so let me quickly clear this up. Let's go to the next page, page 112. Now, page 112, orange portion, this is the one that I sent you through WhatsApp as well. Now, in this case, the basic rules for electroplating, remember these three rules are very important. The object that we are going to electroplate, and let me tell you, we electroplate a lot of objects with different metals. Something which is not quoted over here, but is common in terms of electroplating is gold plating. I hope you understand that gold-plated materials are available around the world. For example, the wristwatches are usually made out of different silver gray metals, but when we want a luxury style watch, we go for gold-plated ones. Those are a little bit expensive. They're not entirely made up of gold. They're made up of steel or copper or other metals. But what we have is a thin layer on top of that steel or on top of that nickel or on top of whatever metal it is made up with. Right? So in order to electroplate that, what we are supposed to do is to take that object as the cathode. The electrolyte must be a solution of the salt of metal M that we are supposed to electroplate on the top of that object. Let's consider this object to be a wristwatch, right? For the sake of understanding. And let's say whatever the wristwatch is made up of, we want to gold plate it so that it has the better appearance. We can sell it for a higher price. And the anode must be made up of the same metal M, which is supposed to be gold. Now, in order to properly understand it, let's draw a diagram. Let's go for an electrolytic tank. Let's say this is an electrolytic tank, and we take our watch. Let's say this is the wristwatch, the poorly drawn wristwatch, but Sir Jahrukh's poor drawing skills. All right, and let's say this one is our anode. And let me tell you, as the rules are given over here, the third rule clearly states that anode should be made up of gold. So the anode would be gold, made up of gold. And here we dip it up. Let's say we're going to dip it up. And this is supposed to be a salt of gold. For the sake of understanding, I'm going to take the chloride salt, which is formulated as AuCl3, gold chloride, and we're going to take its aqueous solution. Remember, the word used over here is solution. So you're supposed to dissolve that in water before you use it in the electrolytic tank. Now, this watch will slowly be plated with a very thin layer of gold. And if you want this layer to thicken, or if you want a thicker layer, go for a more or a longer duration of time. I think it's pretty easy to grasp that if you keep this watch for a shorter duration of time in the same electrolytic tank, you'll get a thin layer of gold. But if you keep this watch for a longer duration of time, you'll get the thicker layers. Now, I hope you understand that the gold lines over here present in the system, that is AU plus 3, which we take from this formula, go from this solution and deposit right on top of this wristwatch. And at the same time, in order to replace these ions in the system, some of the gold particles from this anode will go into the system in terms of gold plus 3 ions, which then replace the ions. Which means by the end of the experiment, by the end of the electroplating process, the amount of gold ions in the electrolytic tank would remain the same, and the anode is supposed to shrink. Why? Because some of the gold would move from anode and the particles will be converted into ions by moving to the system. Remember, this is still electroplating, so both of these are connected to battery. And as cathode is negatively charged, so we need a smaller line over here, and anode is positively charged, so we need a larger line over here, like this. That's how the battery is supposed to be. I hope this diagram explains it. But if you still have questions, go ahead. No questions?
No,
Am I
sir.
audible? Okay, if you don't have any questions, start writing a few important things over here as a part of important points. Point number 1, for thicker layers, electroplating is carried out for longer durations. Point number 1, for thicker layers, electroplating is carried out for longer durations. I hope this point is understandable for everyone, but if at any point you don't understand any of the points, go ahead, shoot the question. Let me know. That's fine, Arham. Just stick to the part, and if you don't understand anything, let me know, Arham. Okay, first point, for thicker layers, अगर आपने लेयर इलेक्ट्रोप्लेटिंग गोल्ड की लेयर मोटी करनी हो तो आप ज्यादा वक्त के लिए इलेक्ट्रोप्लेटिंग का प्रोसेस इस रिस्ट वॉच के ऊपर जारी रखेंगे. रिस्ट वॉच सिर्फ एक एग्जांपल है. दिस कैन बी एनी ऑब्जेक्ट. आप अगर घर रखोगे, स्टील का ग्लास उठाकर इसके साथ ये एक्सपेरिमेंट कर सकते हैं. You can do it with different things, and let me tell you, the cell phones we commonly use are made out of the common manufacturing materials, but there are also cell phones available that are gold plated, wristwatches available that are gold plated, so much so there are cars available that are gold plated. The students, specifically the boys, if they're interested in cars, they must know we also have gold plated cars in the world. And the most richest of the gentry actually affords to get one. I hope at least a couple of boys know about this already. Do we?
Yes, sir. Yes,
The
sir.
one who said yes wants to become rich and buy one. Okay, let's go on with the second point. Now, second point is very important and usually manipulated for most of the past paper questions about electroplating. And this one is pretty simple. Only the part of the object that is dipped inside the solution will get electroplated. Only the part of the object that is dipped inside the solution will get electroplated. अगर आपने ये वॉच आधी डिप की है सॉल्यूशन के अंदर तो आधी इलेक्ट्रोप्लेट होगी. अगर आपने पूरी वॉच डिप की है, पूरी वॉच इलेक्ट्रोप्लेट होगी. अगर वॉच सिर्फ टच कर रही है अपने बॉटम से सॉल्यूशन को तो वॉच का बॉटम ही इलेक्ट्रोप्लेट होगा. रिमेंबर, जितना ऑब्जेक्ट इलेक्ट्रोप्लेट करना होता है हम उतना ही डिप करते हैं, सिस्टम कहता है. So the part of the object that is dipped inside the solution gets electroplated. The rest doesn't. I hope you're done writing point number 2. If you aren't, or if you need to know the point 2 again, let me know. Otherwise, I'm going to move on to point 3.
Can you repeat? I forgot the second word you said.
Only the part of the object dipped in the solution gets electroplated. The rest doesn't. Right?
Yes, sir.
The concentration of metal M ions, this is point number 3. I've started off with point number 3. The concentration of metal M ions in the electrolytic tank remains the same till the end of the experiment. The concentration of metal M ions remains the same till the end of the experiment or till the end of the electroplating. आइंस की जो concentration होती है सिस्टम में वो हमेशा सेम रहती है and I hope you understand the reason क्योंकि आइंस जो होते हैं वो हमारे पास एनोड से ब्रेक होकर पार्टिकल्स आइंस में कन्वर्ट होते रहते हैं सो गोल्ड की concentration सिस्टम के अंदर कम नहीं होती तो गोल्ड आता कहां से अगर गोल्ड की concentration सिस्टम से कम नहीं होती ऑफ कोर्स वो एनोड से आता है which brings us to our point number 4 the point number 4 is let's start with point number 4. The point number 4 is the anode starts to shrink as the time passes during electroplating. Anode slowly shrink hota rehta है electroplating. It keeps on shrinking until there comes a time कि anode जो होता है वो बिल्कुल solution को touch करना बंद हो जाता है बाकी सारा wear off कर जाता है या shrink कर जाता है and there you go the electrolysis the electroplating stops right as soon as the anode is shrunk to a point where it doesn't touch the level of the solution anymore. You're not supposed to write the whole point, just the first line. Okay. The anode starts to shrink as the time passes during electroplating. Okay, and that explains point number 3. All right, we're done with the points. If anyone has any confusion with any of the 4 points, let me know so that I can clear it up. No confusions? Let's go back to page number 111.
Excuse me, sir.
Yeah, sure. Go ahead. Jahrukh.
Sir, can you tell what is metal M?
बेटा मेटल एम कोई भी
Sir,
वो मेटल हो
metal
सकता है
M
जो
क्या
हम
होता है?
इलेक्ट्रोप्लेटिंग में ऊपर पुट करना चाह रहे हैं मसलन मैंने जो एग्जांपल ली उसमें हमने रिस्ट वॉच हाथ पे पहनने वाली जो घड़ी होती है वो कॉमनली कंसिडर की और हम इस एग्जांपल में ये कह रहे थे कि हम उसे गोल्ड से प्लेट करना चाह रहे हैं उसके ऊपर सोना होगा so the appearance of that wristwatch is increased 10 times 20 times than any other original metal, be it steel or nickel or brass or whatever that is made up of. ठीक है तो हमारी एग्जांपल में ये आपने जोन सा मेटल इलेक्ट्रोप्लेट करना आप वो कर सकते हैं and if you let me get back to chapter page 111 you would see giving me a few examples that would make it easy for you that why do we go with specific metals and their electroplating. अभी हम पेज 111 और 12 का टेक्स्ट करेंगे तो आपको आइडिया हुआ कि अगर हम गोल्ड प्लेट करते हैं तो क्यों करते हैं सिल्वर करते हैं तो क्यों करते हैं निकल करते हैं तो क्यों करते हैं या sometimes we even use stuff like chromium or titanium. Why do we do that? That's all a part of the text given on page number 111 and just one starting paragraph on 112. So let me go with these paragraphs and you'll get the extended answer to your question. All right?
सर आपकी आवाज कट रही है।
आपकी आवाज बहुत कट रही है। समझ नहीं आ रहा सर, समझ नहीं आया, आपकी आवाज बहुत कट रही थी।
Can you hear me now?
यस सर।
Yes, sir.
Okay. So मैं ये कह रहा था कि अरहंग क्वेश्चन का आंसर करने के लिए मैं पेज नंबर 111 का टेक्स्ट और 12 का टेक्स्ट रीड आउट करने लगा हूँ ताकि आपको अरहंग क्वेश्चन का ज्यादा अच्छी तरह से आंसर पता चल जाए। ठीक है, वो पेजेस पढ़ते हैं, आपको मेरी बात समझ में आ जाएगी। So let's just quickly clear it up and let's go back to page 111. Okay. So this paragraph at the bottom of page number 111 says, बेटा मेरे पास स्पीड इतनी ही है कि आवाज इस तरह से आए, सो किसी पॉइंट पे मेरी आवाज थोड़ी सी कट रही हो तो थोड़ा बेयर कर लें। जो रिकॉर्डिंग होगी उसमें आपको ज्यादा अच्छा पता चल जाएगा। ठीक है, रिकॉर्डिंग मेरे एंड पे इसलिए की जा रही है ताकि अगर कहीं से भी आपका कोई भी पार्ट मिस हो तो उस पार्ट को देख लें, क्या टाइम है, क्या चीज मैं पढ़ा रहा था, उतना ही पार्ट रिकॉर्डिंग में नोट कर लीजिएगा या सुन लीजिएगा दोबारा। राइट, सो स्टडी टिप पर आते हैं, पेज नंबर 111 स्टडी टिप। इलेक्ट्रोड्स जो इलेक्ट्रोलिसिस में यूज होते हैं वो यूजुअली इनर्ट होते हैं, ग्रेफाइट या प्लैटिनम एग्जांपल्स हैं, ये हम पहले पढ़ चुके हुए हैं। लेकिन इलेक्ट्रोप्लेटिंग में एनोड हमेशा उस मेटल का बना होता है जो प्लेट करनी होती है, ये इनर्ट नहीं होता, ये रिएक्ट करता है। इसी वजह से एनोड का साइज डिक्रीज करता है और वो स्लोली डिसॉल्व कर जाता है। ठीक, अब उसकी कॉमन एग्जांपल देखते हैं। कॉमन मेटल्स जो हम इलेक्ट्रोप्लेटिंग के लिए इस्तेमाल करते हैं उसमें कॉपर, क्रोमियम, सिल्वर, टिन वगैरह आते हैं। देखें, एक पर्पस तो इलेक्ट्रोप्लेटिंग का ये हो सकता है, एंड दिस इज अ वेरी इंपॉर्टेंट लाइन, यू माइट वांट टू अंडरलाइन इट, इज टू गिव अ प्रोटेक्टिव कोटिंग टू द मेटल अंडरनीथ। ठीक है, जो नीचे मेटल होता है उसे प्रोटेक्टिव कोट करने के लिए हम अक्सर ये काम करते हैं इलेक्ट्रोप्लेटिंग। मसलन टिन प्लेटिंग स्टील के कैंस के ऊपर की जाती है ताकि वो रस्ट ना हो। ये जो कॉमनली बेवरेज कैंस मिलते हैं ना, हम इन्हें टिन कैंस कहते हैं क्योंकि इनके बाहर टिन की इलेक्ट्रोप्लेटिंग हुई होती है। अंदर से कैन स्टील का बना होता है, बाहर एक बारीक लेयर होती है टिन की। टिन रस्ट नहीं होता, स्टील रस्ट हो सकता है, सो टिन सेव्स स्टील फ्रॉम रस्टिंग। सो दिस इज द वन स्पेसिफिक पर्पस ऑफ इलेक्ट्रोप्लेटिंग। लेकिन सिर्फ हम टिन पे प्लेट नहीं करते, हम क्रोमियम प्लेटिंग भी करते हैं। आइडिया बिहाइंड क्रोमियम प्लेटिंग आर्टिकल्स such as car bumpers, kettles, and bath taps. Chromium does not corrode. Point 1. Point 2, it is a hard metal that resists scratching and wear. Point 3, it can be polished to give it an attractive finish. कार बम्पर्स का पर्पस ही यही होता है। देखें, कार बम्पर जो है वो रस्ट नहीं करेगा, तो आप कार को किसी भी टाइप ऑफ रोड पे यूज कर सकते हैं। आप जानते हैं बारिश के बाद हम गाड़ियां लेके बड़े आराम से फिरते हैं। वी नो देयर इज सम प्रोटेक्टिव कोटिंग ऑन द कार व्हिच डज नॉट अलाउ इट टू रस्ट। बम्पर की बात हो रही है। 1, 2, वो हार्ड होता है, वो इतने आराम से स्क्रैचिंग या वेयर नहीं होती, तो एक्सीडेंट्स में भी, अगर एक्सीडेंट आसान हो, थोड़ा हल्का हो, ठीक है, यानी बहुत ज्यादा ना हो, सही, तो हमारे पास क्रोमियम जो होता है इतने आराम से स्क्रैच नहीं करता, वेयर नहीं करता, सो इट्स इजी, इट्स safe in terms of metal not getting scratched. All right, and lastly, उसकी पॉलिश की वजह से एक बहुत अट्रैक्टिव फिनिश मिलता है। So any student over here who is interested in cars does understand that the bumpers are specially polished so that the front of the car has an attractive finish. This allows us to sell it for more money, for a better profit. So chromium plating यहाँ पर डिस्कस हुई है और उसके 3 यूजेस डिस्कस किए हैं। टिन प्लेटिंग डिस्कस हुई है, उसका सिंगल यूज हमने डिस्कस किया है। ये सबको समझ आता है? If not, let me know. I can repeat it. If yes, we can move on to nickel plating and stuff.
Yes, sir.
Okay, so we do understand. Let's keep moving on. Attractive appearance of silver can be achieved by electroplating silver on the article made from a cheaper metal such as nickel. निकल सिल्वर हम इसलिए कहते हैं क्योंकि नीचे निकल से बना होता है, निकल एक चीप मेटल है, ऊपर हम सिल्वर का फिनिश दे देते हैं, एक एक्सपेंसिव मेटल है। We do the same thing with gold. हम पूरी चीज गोल्ड से नहीं बनाते। Wrist watches are not entirely made of gold. They are only plated with gold, which keeps them less expensive and gives them a good attractive finish. The EPNS seen on cutlery and other objects stand for electroplated nickel silver. Cutlery is also made out of electroplated nickel silver. So we make the cutlery out of nickel, but we only electroplate it with silver, which does not let it get rusted or get corroded over a period of time, because cutlery has to be dipped in food which might be acidic or alkaline. A lot of our foods are acidic actually. Nickel silver is an alloy of copper, zinc, and nickel. It contains no silver at all. It is used as the base metal for silver plated articles, which are later on electroplated with silver, which pretty much explains it. The price, the finish, everything. So any questions from electroplating part? We have
No, sir.
hardly 3 minutes left, so let's wind up this chapter. We're already done with tables at the bottom of page 112. We are done with the orange portion at the bottom of page 113 and the table at the bottom of page 113. The last topic we need to do is present on the right hand side by the name the refining purification of copper by electrolysis. It's actually not electrolysis, it's electroplating. हम कॉपर को रिफाइन करते हैं इलेक्ट्रोप्लेटिंग से बहुत आसान सा प्रोसेस है देख लें. At the start of the process, the cathode is made out of pure copper, as stated over here, and anode is made out of impure copper. This system is actually a solution of copper 2 sulfate, but it's acidified for it to become a better electrolyte. What happens is that the anode, impure copper, dissolves into the system. The solution copper ions gets deposited on the cathode. This is the before part of the experiment, and at the after part of the experiment, you would see the cathode has fattened. मोटा हो गया cathode. वो copper खा खा के मोटा हो गया, ठीक है? और anode जो है, you would see that it has wore off. A lot of it has dissolved in the system. But there is another heading over here. We can see the label of by the name of anode sludge. This is not given over here, so let's read it on the next page 114. On page number 114, it says that we use copper in electrical wiring. It's for conductivity purposes, but it has to be pure. Now, copper, when we dig it out of the earth, does not have that kind of purity. However, we go with this process, refining of copper. The cathodes are made out of thin sheets of pure copper. Now, during the refining process, pure copper is removed from the impure anodes and is deposited on the cathodes. Any impurities fall to the bottom of the cell. Now, this material is known as anode sludge. Now, what does anode sludge contains? It contains precious metals such as gold, silver, platinum. This can be purified from the sludge and can be sold for a better price. Anode sludge is not thrown away. Remember, the key observations during electroplating are that the object thickens as it becomes plated, the anode dissolves away, the electrolyte maintains the same concentration, just like we studied in the previous 4 points. Thus, if it is colored, the intensity of color stays the same. This is a very important study tip. Remember that for paper 6 as well as for paper 2. This is important for ATP as well as for MCQs. Which brings us to the end of this chapter. Any questions from the refining of copper part?